Hi guys, welcome back to my channel. Before we start our new math lesson for today, please don't forget to hit the subscribe button and the notification bell for more videos. Today we're going to talk about equation of a circle. So in this specific lesson, we're not going to talk about the different theorems about circles. Rather, we're going to talk about on how we can actually form the equation of a circle using its center and radius and vice versa. Now, what are the MELCs or learning competencies for this? So we're going to illustrate the center radius form of the equation of a circle, and we will also determine the center and radius of a circle given its equation and vice versa. So these are the target competencies that we are going to have here. Now, so let's have the center or equation of a circle wherein the center is at the origin. So if the center or of the circle is at the origin, for all we know, when we say origin in a Cartesian plane, it has coordinates of 0, 0. Again, when we say the origin, the coordinates are 0 and 0. So to better understand this, let's have first a recap about the Cartesian coordinate plane. So let's say this is a perfectly made Cartesian coordinate plane wherein we have axes. So the x-axis and the y-axis. Now, at the middle or the intersection of the x and y-axis, this is what we call the origin, and it has coordinates of 0, 0. And then, let's identify the quadrants in counterclockwise direction. So this is the first quadrant, and in the first quadrant, the signs of the coordinates are for the x, we have positive, and then for y, we have positive. So x and then y, they are both positive. And then for quadrant 2, this is the quadrant 2, the signs are negative and positive. Okay, we have negative for the x coordinate, and then y coordinate is positive. And then for the third quadrant, the signs are both negative. And then for the fourth quadrant, the signs are positive and negative. So if that's the case, if the circle is drawn wherein its center is at the origin, so this is now the circle. Okay, so and then the distance from the center up to any point of the circle is what we call the radius. So this one is what we call the radius. So the equation of a circle now is x squared plus y squared equals r squared. Again, it is x squared plus y squared equals r squared, wherein r is what we call the radius of the circle. Okay, so just remember that if the center is at the origin, the equation of a circle that we're going to form is x squared plus y squared equals r squared. Let's proceed. How about the standard form? The standard form or the center radius form, okay, goes like this. So if the circle is not at the origin and the center is at hk, so it means that the center of the circle is at any point on the coordinate plane. So it's not at the origin. So we're going to use now the equation quantity x minus h squared plus quantity y minus k squared equals r squared. So wherein h and k are what we call the coordinates of its center. Okay, so just like in this illustration, as you can see, the center of the circle is located at quadrant 1. Okay, so the center is not actually at the origin. That's why we will be using this. Now, if you're going to ask me, are they just the same? Yes. So if the center is at the origin, the coordinates are 0, 0. So if we will just substitute, we have x minus 0 squared plus quantity y minus 0 squared equals r squared. So if we're going to simplify this, x minus 0 is x squared, and then y minus 0 squared is just simply y squared equals r squared. So as you can see, the equation of a circle wherein the center is at the origin is just derived from this standard form of the equation of a circle. So if you have questions about the difference, additional questions or queries about the difference between the two equations, just inform me. Or the standard form and the equation of a circle wherein the center is at the origin, you can actually ask questions, most especially to my students. Now, let's have the first example. Write the equation of a circle with center at the origin, and the radius. So it means if the center is at the origin, it has coordinates of 0 and 0. Okay, so if that's the case, which of the two equations are we going to use? We are going to use the equation wherein the center is at the origin. Now, all we need to do, if the center is at the origin, just substitute the value of the radius, which is 8. So we have now x squared plus y squared equals 8 squared. So just simplify, 8 squared is 8 times 8, or 8 squared is what? The answer is 64. Okay? And then just bring down x squared plus y squared. So if you're going to ask me if this is already the standard form of the equation of a circle, yes. So this is now our answer. X squared plus y squared equals 64. Okay? Next. Write the equation of a circle wherein the center is 5, negative 2, and the radius is 4. So as you can see, the center of the circle is not at the origin. So it means that we're going to use the standard form, or the center radius form, which is quantity x minus h squared plus quantity y minus k squared equals r squared. So all we need to do is to substitute the values. So for h and k, so this is what we call the h and this is the k. Now, for the h, it is 5. So when you're substituting, get the opposite of this, and then that's it. Okay? So we have x, and the opposite of positive 5 is negative 5. As simple as that. Plus y, and the opposite of negative 2 is positive 2 square equals r, which is 4 square. So 4 times 4 is 16. The standard form of the equation of a circle wherein the center is 5, negative 2, and the radius is 4 units is quantity x minus 5 square plus quantity y plus 2 square equals 16. So when you are substituting the h and k, the real process is this. Okay, so we have x minus quantity 5, or positive 5 square plus quantity y minus quantity negative 2 square equals 4 square. So this is the real process. We just skipped it. Just remember that we can just simply get the opposite of 5 and opposite of negative 2, because it was like this. So negative times 5 is just negative 5 square, and then negative times negative is positive 2. So that's why it's just the same as this. Okay, so the shortcut is just when you are substituting h and k, just get the opposite of the coordinates. Okay, let's proceed. This is now the answer here. Next. Example number 3. Find the center and the radius of, okay, so quantity x plus 6 square plus quantity y minus 3 square equals 100. So in this case, we're looking for the center and the radius. In the previous examples earlier, we are looking for the equation of a circle using its center and its radius. So this time, we are going to write the equation of a circle using the center and the radius. Now, how? This is what are we going to do now? Okay, so to get the center, just remember that get the opposite of positive 6 and get the opposite of negative 3. This will serve as your h, the 6, and then this one is your k. So your center now is opposite of positive 6 is negative 6, and opposite of negative 3 is positive 3. So that's your center. And then for the radius, consider the right side of the equation, which is 100. And then get the square root of 100. Your radius is 10 units. Okay, so your answers are, the center is negative 6, 3, and the radius is 10 units. Okay? Simple as that. Now, find the center and the radius of the circle. Okay, so given the equation x squared plus y plus 9 squared equals 81. So how are we going to find for its center? Just remember that this, if you have this kind of term in the equation of a circle in standard form, just remember that it means that the value of either h or k is 0. So it means that h is 0. And then here, how about k? Get the opposite of positive 9, which is negative 9. So this is now your center. How about for the radius? So for the radius, get the right side of the equation. The square root of 81 is just 9 units. So your center is 0, negative 9, and your radius is 9 units. Okay, I hope you can follow with the discussion. Next. Example 5. Find the center and the radius of x squared plus y squared minus 6y equals 0. So if you will be seeing this type of equation of a circle, this is not written in standard form. Rather, this is written in general form. What we're going to do now, before we can get the center and the radius, we will be converting or transforming this into standard form. So how? we have to regroup the things that we can use for h and k. So for h, we can use this. And then for k, we can use y squared minus 6y. So that's regrouping. Now, we don't have any problem with x squared because the h here is, it means it's 0. Okay? So we will rewrite x squared minus, okay, the other terms that we regroup, we have y squared minus 6y. So in this case, we have to make this as perfect square trinomial. Okay? Equals 0. So how are we going to do that? We are going to use completing the square. So what is completing the square? We are going to complete the third. This trinomial, okay, wherein by getting negative 6. Let's process this. So get negative 6 and then divide it by 2, you will be getting negative 3. Then so once you got negative 3, square negative 3, or the quotient, which is negative 3, you will be getting positive 9. So get positive 9. We will be adding positive 9 to complete the perfect square trinomial. And just remember, to make the equation balance, you have to also add 9 to the right side of the equation to make it balanced. So whatever you give to the left, you have to also give it to the right. Okay? So we already have the perfect square trinomial. What are we going to do next? We're going to factor this. So when we're in, we just get y, or this is plus. We just get y, and then get the sign of the middle term, which is negative, and then square root of the third term, square root of 9 is 3 squared. So 0 plus 9 is 9. So as you can see, it's now written in standard form. So question, Teacher Dong, are we able to get now the center and the radius? Yes. So the center is, h is 0, and your k is positive 3. Get the opposite of negative 3, it is positive 3. Now, how about your radius? Your radius is square root of 9, which is 3. So your center is 0, 0, 3, and then your radius is 3. Okay? So just follow the process. So if it is written in general form, you have to transform it in standard form before you can actually get the center and the radius. So just follow the process. You have to form a perfect square trinomial, and then after forming, okay, so you can now get the center and the radius because it's now written in standard form after you factor the PSC, or the perfect square trinomial. Now let's have the same example as this so that you will better understand. Now, example 6. Find the center and the radius of x squared plus 18x plus y squared minus 8y equals negative 16. So this is still written in general form. We will transform it in standard form by regrouping. So we will regroup and we will get h from this one, x squared plus 18x, and we will get k from this, y squared minus 8y. So we will be forming both PST. Okay, so this time we have to a while earlier now. Now, let's have this. We have x squared plus 18x, and then leave a space, plus y squared minus 8y, then leave a space, equals negative 16. So get 18. So 18 divided by 2 is 9, and then square the answer, which is 9. 9 squared is 81. So you will be adding 81 here. Okay, so to make the equation balance, you have to also add 81 in the right side of the equation. Next, let's have negative 8. So get negative 8 and then divide it by 2. You will be getting negative 4. Then square negative 4, you will be getting positive 16. So we will be adding positive 16 here. We will also be adding positive 16 in the right side of the equation. So can we now factor? Yes. So x squared plus 18x plus 81 is now x. Sign of the middle term plus square root of 81 is 9 square plus y. Sign of the middle term negative, and then square root of 16 is 4 square. Then negative 16 plus 81 plus 16 is just simply 81. Can we now get the center? Yes, what is the center? Very good, it's 9, negative 9, and positive 4. And your radius is square root of 81 or 9. Okay, so as simple as that. Okay, so if it's written in general form, you have to transform it first into its standard form to get the center and its radius. So I hope you can follow. Okay. Next, let's have number 7. Number 7, we need to graph. Graph the equation quantity x plus 2 square plus y minus 3 square equals 16, or quantity x plus 2 square plus quantity y minus 3 square equals 16. So in this case, before we can actually graph this one, we have to identify the center and the radius. So we can easily identify the center h and k. Okay? So positive 2, this will become negative 2, negative 3, positive 3. So this is now your center. And then from the radius, just get 16. Square root of 16 is equal to 4. Now, can we graph? Yes. So first is graph the center or plot the point of the center, which is negative 2, 3. Where's negative 2? This one. And then positive 3. So going up, 1, 2, 3. So this is positive 3 for the y. So this is now the center, negative 2, 3. Now, how are we going to form the circle? Get the radius, which is 4. Just remember that the radius is from the center up to any point of the circle. We are just going to do upside down. Do it upside down. So from this up, count 4 units. 1, 2, 3, 4. And then right, count 4 units from the center. 1, 2, 3, 4. And then down, count 4 units from the center. 1, 2, 3, 4. And then left, count 4 units from the center. It's 1, 2, 3, 4. Okay, so we can now form the circle. Let's say this is a perfectly done circle. Okay, so sorry, I'm not a perfect person, and it's hard for me to draw the circle. It's hard for me to draw the circle in this using this gadget. Okay, so let me erase it. Okay, so let's have this. Down, and then the right point that we form, and then so let's say this is a perfectly done circle, and this one is the radius, which is 4 units. So the equation of this circle, you have to put it also when you graph. It's x plus 2 square plus y minus 3 square equals positive 60. So that's how you graph the circle. All you need to do is the center and the radius. So I hope you can follow. So for those who have questions and clarifications regarding the equation of a circle, please feel free to comment down, and for my students, you know how to contact me. So for my students as well, please do the following activity. Okay. Now, so I thank you for your support. And then for those who are not yet subscribed, please hit the subscribe button below and the notification bell for more videos so that we can record for more. Okay. So thank you so much, and I hope that you will have a good day.